In the next chapter, we will look at an overview of DMAIC. DMAIC is a data-driven Six Sigma process for improving existing products and processes. The DMAIC process should be used when an existing product or process requires improvement to meet or exceed the customer's requirements. This initiative should be consistent with the business vision, strategy, and goals of the organization. The examples of companies using DMAIC methodology are GE, Motorola, and many others. GE uses DMAIC to reduce invoice defects and disputes by 98%, speeds up payment, and creates better productivity. Let us see what exactly DMAIC stands for. D stands for define the problem. M is to measure the outcome. Y to determine the current process performance baseline and validate the measurement system. A is for analyze, identify X's, root causes of the defects, variation sources. I stands for improve the process by eliminating defects. C means to control X's for sustained performance. Now we will look at each of these phases. Each of these phases has inputs, tools, and outputs. The inputs of the define phase are need for a Six Sigma project, executive management sponsorship. The tools used in this section are organization hierarchy, high-level process maps, high-level Pareto charts, idea generation and categorization tools. The outputs of the define phase are project charter, established metrics, problem statement. Roles and responsibilities. The next phase is measure. The inputs here are project charter, roles and responsibilities, problem statement, stakeholder requirements, established metrics. The tools recommended for this phase are data collection tools and techniques, detailed process maps, cause and effect diagrams, flow charts, brainstorming, statistical distributions, probability, gauge R&R study. The expected outputs are well-defined processes, baseline process capability, process parameters affecting CTQ, critical to quality, cost of poor quality, COPQ, measurement systems. The next phase stated is analyze. The inputs for this phase are well-defined processes, baseline process capabilities, process parameters affecting CTQ, critical to quality, cost of poor quality, COPQ, measurement systems. The necessary tools here are failure mode and effects analysis, data analysis, hypothesis testing. The outputs of this phase are important causes of defects, performance gaps, special and common causes of variation, cost and benefits of proposed solutions, points of failure. In the improve phase, the inputs are important causes of defects, performance gaps, special and common causes of variation, cost and benefits of proposed solutions, points of failure. The tools required in this phase are Solution Design Matrix, Design of Experiments, Taguchi Robustness Concepts, Response Surface Methodology. The outputs of the improve phase are cost and benefits of different solutions, process capability of proposed solutions, selection of solutions for implementation, implementation plan. The last phase is control. The inputs of this phase are cost and benefits of different solutions, process capability of proposed solutions, selection of solutions for implementation, implementation plan. The tools used are data collection methodology, control chart, 5S, Kaizen, Kanban, total productive maintenance, cycle time reduction, measurement system reanalysis. The outputs of the control phase are implemented solutions, revised measurement systems, control plans for sustaining benefits, improved process capabilities, and lessons learned. Let's learn about each phase in detail. The define phase is used to identify areas to improve and defines goals for each improvement activity and ensures that resources are in place for the improvement project. The define phase focuses on customer requirements and identifies projects' CTQs, critical to quality. Each CTQ is a product or service characteristic that satisfies a customer's requirement or process requirement. The measure phase evaluates the process of determining the current process performance. This is the baseline. It uses exploratory and descriptive data analysis to help understand the data. The measure phase allows you to understand the present condition of the process before you attempt to identify improvements. The inputs to the measure phase are the outputs of the define phase. The analysis phase is used to identify a few vital causes from a list of potential causes obtained from the measure phase that actually affect project outcome using Six Sigma methodologies. The data collected in the measure phase are examined to determine a prioritized list of the sources of variation. The improve phase of Six Sigma is used to improve the system to do things better, cheaper, and more rapidly by finding the optimum solution for why, implementing the new approach, and validating it using statistical methods. The main objective of the improve phase is to improve the process by eliminating defects. The control phase of Six Sigma is used to develop and implement the process control plan to ensure continuance of the improved process. The major activities of the control phase are to validate the measurement system, verify process improvement, and develop a control mechanism. Before arriving at the control phase, we have identified the best settings for each of the vital X's. The key now is to ensure that the X's do not drift from their targeted settings. Process control is an important tool to ensure that the Six Sigma project delivers lasting benefits. With this, we come to the end of the session. We hope you've enjoyed it.
For more information on trainings and certifications, visit our website at www.isoleansigma.com or www.sixsigmaplus.com.